So we're going to be solving test chapter 4, form A. The first question in this test, they're asking us, what mathematician found the formula for the area of a circle? And that mathematician name is Archimedes. So I'm going to write Archimedes. And where did he live? He lived in Syracuse, Sicily. So Syracuse, let me spell that. Syracuse, Sicily. Sicily. In what year did he die? He died in the year 212 BC. What word did he shout naked? Eureka. So let me Eureka. Why was he naked? Well, he was naked because he was batting. So he was batting. So this is a little bit of history that they're gonna be asking you in this particular test. Question number 2. A wheel rolls 175 pi feet while making a revolution. Find the wheel's diameter. Well, whenever we're talking about distance and revolutions, so recall this formula. That is the number of revolutions. So I'm going to write here the number of revolutions times the circumference of a circle is equal to the distance. Now, they're giving us the number of revolutions, so we know this part here. They're not giving you the circumference, but they are giving you the distance. So maybe we'll be able to find the circumference, but the overall question is to find the diameter. And also recall that this circumference is actually pi d. So that will give us our formula. And here the distance in this case is 176 pi, and the number of revolution is 8. So we can easily find d here. We're going to divide each side by 8 pi. I'm going to rewrite my formula. So we have 8 pi d equal to 176 pi. So we're going to divide each side by 8 pi. Divide each side by 8 pi. And after we do this, the diameter is actually equals to 22. 22. And what units are we talking about? Feet. So 22 feet. So that should be your final answer for problem number 2. So just remember, the formula is so important. This formula here, the number of revolutions times the circumference equals to the distance. You must memorize that formula. Number 3, PQR are points. Number 3, they're saying that PQR are points in a circle with center C. And at the same time that the angle CPQ is 40 and the angle QCR is 137. Find the measurement of the angles PCQ and PRC. So first of all, I'm going to try to draw my circle here. I'll try to make a circle here. Okay, so that's going to be my circle. So let me erase this a little bit here. There we go. We have a circle. So with center C. So let's just put a C here. And at the same time, we have PQR. So I'm probably going to write here a P and a Q and an R somewhere here. And they're saying that the measurement of CPQ, CPQ is 40 degrees. And at the same time, QCR is 137 degree. find the measurement of the angles PCQ. So I'm going to write PCQ. PCQ should be here. Now let me call this X. Okay, and we're going to call this X. And PRC. PRC. So PRC is going to be PRC. PRC. So it should be here. I'm going to connect these guys here. PRC. So this is probably going to be Y. Okay, I'm going to call this Y. So let's start solving this. How are we going to solve this? Well, recall that we're in a circle and C is the center. So this side here and this side here are the same. And as well here. So if we look at this part here, this triangle, we're actually going to have an isosceles triangle. So I'm going to probably zoom in here and look what's going to happen there. We're going to have P, Q, C. Here's an isosceles. Here's 40 and here's 40. And this is the angle X. So 40 plus 40 plus X should equals to 180 degrees. So 80 plus X equals to 180. Minus 80 minus 80 each side, you're going to have the X is equals to 100 degree. And at the same time, that X is actually the measurement of the angle PCQ should be equals to 100 degrees. Alright, so now let's try to find Y, or the angle PRC. How are we going to do that? Well, let me write here that this part is 100. And at the same time, well, if this is Y, this part here should be Y as well. So this should be Y. Now, we also know that in here, in this, around the center C, all of these should add up to 360 degrees. So let me probably call this C, just this angle. So I know that 100, so there we're going to have 100%, sorry, 100 plus 137 plus C should equals to 360 degrees. Now we're going to add these two up. 237 plus C equals to 360 degrees. So if I am going to use my calculator, what are we going to get? Well, we're actually going to subtract minus 327 each side. So if I subtract 307 each side, let's see what are we going to get. C equals to 360 minus 237, which gives me 123. 123 degrees. So C, that part, that number here that we label it C, should be equals to 123 degrees. So in this part here, I'm going to zoom in now. Look, this part here, this triangle here that we have in the bottom, the triangle PCR, this part here, PCR, which has an isosceles triangle here, and this is Y, and this is Y, and this is just the one we just found is 123. So we're saying there that Y plus 123 should be equals to 180 degrees. So I'm going to subtract 123. Well, first of all, combine like terms to Y plus 123 equals to 180. You subtract each of them in each side, and let's see what we get. 123 each side, so 2y equal to 180 minus 123. That gives us 57 degrees. If you divide each side by 2, we're actually gonna have that divided by 2. We have 57 over 2, which is 28.5 degrees. So this should be 28.5 degrees. That should be your answer. Or you can also say I'm actually gonna have 28 and 1/2 of it, so it will be 30 seconds. Therefore, because y is the measurement of the angle PRC, this should be equals to 28 degrees 30 minutes. So this should be your answer for problem number 3. Number 4. Find the perimeter and the area of the given figure, where ABCD is a rectangle. So if this is a rectangle, let's just say this is a rectangle. So if this part is 20, this part here should be 20. And well, this part here should be congruent to this part here. And they also say the BC is a semicircle. So the center should be around here. So if this is 20, this part should be 10. And this part should be 10. In other words, the radius is 10. So if the radius is 10, from here to here is 10, then if all of this is 33, then DC should be 23. So DC should be 23. We're going to apply here 23. 23. And this part should be 23 as well. And we're talking about feet. So here should be feet. Now we're trying to look for the area and the perimeter at the same time. Let's find the perimeter. So to find its perimeter, recall that the perimeter is the sum of all the sides. So I'm going to have this 20, 23 plus the circumference plus another 23. Well, first I'm going to have to find the circumference of that circle then. So it's going to be of the 20, the P is equals to 20 plus 23 plus, well, half the circumference of that, which is 1/2 pi r. Well, 1/2 the circumference of the whole circle. And let's just put here, circumference is equals to 2 pi r. If I'm looking for half a circumference, 1/2 of a circumference should be 1/2 of 2 pi r, which just give us a 1/2 of a circumference is just pi r. So here we were supposed to have only pi r. So I'm gonna have here pi r plus 23. Well, also remember that r is 10, so I'm gonna have the P is equals to 43 so far. Well, 43 plus 23, what is that going to give us? I think that should give us a 66. That should be a 66. Let's double check that. 66. Yes, that should be a 66. So I'm gonna have a 66 there. 66 plus r in this case is 10. This one here was 10. So I'm gonna have 10 pi. What units are we talking about? Feet. So the perimeter should be 66 plus 10 pi. Now let's try to find the area. So I'm gonna erase this part here. Just that was to find half of the circumference. Okay, so now they're looking for the area, and we gotta decompose this figure, and that's actually going to be the area of a rectangle who has size of 23 by 20 plus the area of a semicircle. Recall that the area of a circle is equals to pi r squared. So if you're looking for a semicircle, the area should be 1/2 pi r squared. And the radius here was 10. And what is the area of this rectangle here? Base times height. So the area of the given figure should be base, which is 23, times the height, which is 20, plus 1/2 pi r, which is 10, square. So what are we getting here? Area is equals 23 times 20 should be 460 plus Well, be careful here. This is going to be 1/2 pi times 100. And simplifying that, area is equals to 460 plus 50 pi. All of this is in square feet. Are we done with everything? Looks like it. However, if you recall, if you read the instructions, it says give both the exact answer and then round it to the nearest thousand. So both of these answers were the exact solutions, the exact answers. We need to find the approximate solution in order to receive full credit. Because just for this particular problem, they're telling you to give both of them. Okay, so let's get to the habit of that. So the perimeter is approximately, if I put everything on my calculator, 66 plus 10 pi, what is that going to be? That the calculator says 97.41592. Well, I'm rounding it off to the nearest thousands. Tens, hundred, thousands should be here. So the perimeter is approximately 97.416 feet. This should be your approximate solution. Now let's do the area. Area is approximately 460 plus 50 pi, and the calculator says that this is actually 617.0796. Let's round it off to the nearest thousand. 10, 100,000. So this should be approximately 617.080 square feet. So that's how we're gonna do problem number 4. To find the perimeter, we needed to find half of the circumference. And also to find the area, we needed to find the area of the rectangle plus the area of the semicircle. Don't forget that they were saying here specifically, they were saying give both the exact answer and then round it off to the nearest thousand. So always read the instructions. And the units are feet, so everything is feet, good. And my area should be a square feet and a square feet. Perfect. Let's move on to the next following problem. Problem number 5. Find the perimeter and the area of a 54 annular sector with inner radius of 20 inches and outer radius of 30 inches. Give both exact answer and then round it off. So what we're going to do here, we're going to first try to visualize what they're asking you. So here I'm going to try to draw my annular sector. So here, something like this, with a 54 degree, and this says that this inner part is at 20 inches and all of this is 30 inches. Therefore, by default, this should be 10 and this part should be 10. To find the perimeter, I need to know this arc length of the inner one and the arc length of the outer one. So let's first find the arc length of them. So to find the arc length, we have to do, let's focus on the inner first, the inner circle, which has radius of, what is the radius of this guy? Radius is 20. So I'm going to have to sector is to full circle. And the degree here. And here we're going to have the arc length. So what is the sector here? The sector of degree is 54 and the full circle should be 360. The arc length is x and the arc length of the entire circle is 2 pi r. 2 pi r, which is 20. So let's solve for x. 54 over 360 equal to x over 40 pi. you have to reduce. Well, I'm going to reduce this to 54 over 360. I believe 9 goes into both of them. 9 goes into here 6 times, and 9 goes into here 40 times. If I keep reducing that, I'll have half of this 3, half of this is 20. So overall, we have 3 over 20 equal to x over 40 pi. I'm gonna multiply each side by 45 to leave the x by itself, and that gives us, simplifying, 6 pi equals to x. So therefore this part is 6 pi. Now we're gonna do the same technique for the outer circle. So I'm gonna probably write here outer. I'm going to use the same technique. So outer circle, r equals to 30, right? And we're going to have sector, full circle in degrees. So it's 54 degrees is to 360 degrees as the arc length of this case is y is to 2 pi r, which is 30 in this case. Whenever you reduce this left side fraction here, we were left with 3 over 20 equals to y over 60 pi. So now multiply times 60 pi each side, times 60 pi each side. We're actually going to get, this goes into here once, goes in here 3 times, 9 pi equals to y. Alright, so I have this one is 9 pi. Therefore, my perimeter should be this 10 plus 6 pi plus 15 pi plus another 10. So therefore perimeter, let me write here perimeter is equal to, well, p equals to 10 plus 10 is 20 plus 6 pi plus 9 pi is 15 pi. All right, so I'm going to write again. So p is equals to 10 plus 10 plus 6 pi plus 9 pi. And that simplifies 20 plus 15 pi. This is the exact solution. And let me find the approximate solution. So if I put that in my calculator, I should be able to get 20 plus 15 pi. I'm going to have 6, and round it to the nearest thousand. I will round it up to the nearest 67.124. Do not forget about your units. So we're talking about inches. So each of them should be inches. Okay, so that's the perimeter and the exact solution and the approximated solution. Now let's do the area here. In this side of this side, we're gonna do the area. So I'm gonna do this. So we gotta find the area. How are we gonna find the area? We're gonna use the same technique. We're doing sector to full circle, but in this case, we're gonna do degree to area. But to find the area of all of these, we must first find the area of the entire annulus sector, because we're going to be doing sector is to, well, actually going to, yes, area of the sector of the annulus, right, of the piece of it, plus the full annulus, okay, or the entire annulus. But first of all, find the area of the entire circle, so the entire annulus. So the area of an annulus here, the area of annulus, actually the formula is area is equals to pi big R minus a small r, each of them is square. So area is equals to pi, big R is 30 degrees, 30 square, sorry, minus 20 square. Using a calculator, let's find out what we're gonna get. 30 square is 900, minus 30, we're gonna get 500, minus 20 square, which is 400, we're actually gonna get 500. So area is equals to 500 pi. So that's the entire annulus, okay? So whenever we go back to this, the degree of the sector is 54, and the entire annulus is 360. the area of what we're looking for is, let's call this one, let's just call this C for now. Let's call this C. Entire annulus should be 500 pi. Now, I'm going to use same proportion, 54 over 360 equals to C over 500 pi. Well, recall that whenever you reduce this part, end up being 3 over 20 equals to C over 500 pi. Multiply each side by 500 pi, and let's see what we're going to get. We got to reduce this part here, right? Cancel out, and then here 1 0 with 1 0. 2 goes into 50 25 times. So you're actually going to have 75 pi is equals to C, and that was actually the area, right? So the area of the 54 annular sector, 54 degree annular sector, is actually 75 pi. What type of units are we having here? Square inches, or which is approximately, let's see what this approximates, 75 pi, and round to the nearest thousand, we should get 235.619 square inches. So to find the perimeter, we needed to find the arc length, and to find the area, we also needed to find the area of the entire annulus. Problem number 6. In problem number 6, they're telling us that AD is tangent at D to a circle with center C, and AC meets the circle at B, given that AB is equals to 8 and AD is equals to 16. Find the radius of the circle. What we must do first is to picture our circle. So I'm probably going to have a circle here with center C, and they say that it's tangent, there is a tangent, AD is tangent at D. So probably D, let's call it here, and there is a segment here, probably A around here. And they also say that AC meets the circle. So if I have a segment here, AC meets the circle at B. And the given that AB, this part is 8, and the AD is 16. Find the radius of the circle. So if they're asking for the radius of the circle, the radius is pretty much this part here, from here to this point, X. And also that recall that the areas from anywhere from the center to any point is X. To here is X, to here is X, to here is X, and also from here to here should be X. And whenever you find a tangent line with the radius here, this part should be 90 degrees. So this tangent line is perpendicular to the radius of the circle. So by being perpendicular, here we have a Pythagorean theorem. 16, 8 plus X, and X are the side of this triangle. Oh, we could probably apply Pythagorean theorem. So using Pythagoras, right, Pythagorean theorem, we're going to get that the hypotenuse, X plus 8 square, is equal to X square plus 16 square. Let's FOIL this part here, or if you remember the formula, that's the first square plus twice the product, which is 16x, plus the second one squared, which is 64. Or you can remember, you can always FOIL this part here, okay? Or you use the one that you feel the most comfortable with. Now this part have x squared plus 16 squared. Let's see what is 16 squared. 16 squared is 256. Now I'm going to move everything to one side. So minus x squared each side. First, I no longer have in a quadratic equation. So subtract 64 each side. Let's see what we get. 16x is equals to 256 minus 64 should be 192. Divide by 16 each side. Therefore, x is equals to, let's see, 192 divided by 16 give us 12. Therefore, the radius of the circle should be 12 units. Problem number 7. Inscribe a circle in this point. Inscribe means to put inside. So we're going to have to put a circle here. So maybe around here. I'm going to try to make my circle neatly. So, but yeah, your circle should be here. Okay, it's touching the 3 parts here. 1, 2, 3. So that should be your circle. Inscribe. So it means inside. Now, circumscribe around. So the word here is telling you around. So you got to put it around all these vertices should pass a circle. So probably the radius is, the center is probably somewhere here. So I'm going to try to use my artistic skill. So yeah, around there. So that's how your circle should be. So all of these are being connected. Okay, every vertex must pass through the circle. So circumscribe a circle is you kind of put the circle outside the given figure. Problem number 8. Find the area of a region between the circle and the regular hexagon. So probably they want the area between them, so it's just this space. This is the area that they want you to find. This little piece, which means the first we must find the area of the entire hexagon and then get rid of the area of this circle, who's going to have some radius here. Okay, they say that each side is 8 meters, so this side is 8, so all of them is 8. Now, to find the area of a hexagon, let's just recall what is the area of the hexagon. Area of an hexagon of a regular hexagon is 1/2 AP. So we need to know the apothem, which we don't know it yet. So, and also the area of a circle, I'm gonna write here with white. Area of a circle, just recall that is pi r squared. So we need to know all of this here. Now, the apothem is the distance from here to here, as we did in the previous chapter. If it's a regular hexagon, I can have an equilateral triangle here. This should be the radius here, right, from here to here. And here should be 60 degrees. It should be 60 degrees as well. Okay, how are we going to find the A? Okay, and how are we going to find this side? Well, this side here should be, half of it should be 4 and 4. So if I actually visualize this part here, I'm going to put it like this. I have a 90 degrees here. I have A and I have 60. And by default, this should be 30 degrees. And I have 4 in here. So we're going to have a right triangle there. So erase this part here. And recall that in the previous chapter, we learned about 30, 60, 90 triangle. So this is my long side. This is my small side, and this is my hypotenuse. And also recall that the formula says that long side, because actually that's what I'm only looking for, should be equal to S root 3. And we know S. S is 4. So L equals to 4 root 3. Oh, but this L actually happens to be A. So the apothem is 4 root 3. And we're talking about meters. So probably we forgot to write this here. Meters. Okay, so now I have the apothem. The perimeter is easy to find. Recall that you're looking at the hexagon. So that's actually just 6 times the size of each of them. 8. Do we have the radius? Well, also that the radius happens to be the apothem. So this is also the radius. Besides being the apothem, is also the radius, okay? Also the radius. So we have everything. Let's find the area between them. So the area of the shaded region is actually the one from the hexagon, the area of the hexagon, the regular hexagon, minus the area of a circle with radius 4 root 3. Okay. Now area is equals 1/2 AP. I'm going to write my formula. Minus pi r squared. Area is equals 1/2. The apothem is 4 root 3. The perimeter is 6 times 8 minus pi r squared, which is 4 root 3 square. So let's do the math in here. So I'm going to probably have to simplify some things here. This goes into here twice. Then I'm going to left with 2 times 16 times 8. 2 times 16 times 2 times 6 times 8. Let's see, 2 times 6 times 8. 2 times 6 times 8. We're going to get 96. So I'm going to have 96 root 3 minus, oh, this is the hard part. So this is square for each of them, okay? So it's actually going to give you 16 times root 3 square, which becomes 16 times 3 pi. So area is equals to 96 root 3, 96 root 3 minus 48 pi. This is my exact answer, which is with square meters. But I also want the approximate solution. So I'm going to crunch everything on my calculator. 96 square root of 3 minus 48 pi. And that's going to give us 15. I'm going to round it already. 15.480 square meters. The exact solution and the approximate solution. To round it to the nearest thousand. So to find that shaded part, the space between them, we had to find the area of the entire regular hexagon, which we needed to know its apothem, and subtract the area of the circle. Number 9. Find the area of the region between the circle of diameter 10 feet and a square. So pretty much they're asking you to find the area of this part here. For that, we need to get the area of the entire circle and chop or take away the area of the rectangle. So let's recall our formula. So area of a circle is equals to pi r squared, and area of a square is equals to the side being a square. Now, to find the area of the circle, I need to know its radius. But they give me the diameter. And also recall your diameter is equals to twice the radius. If diameter is 10, then the radius should be 5. And we're all talking about feet, so I'm probably going to put feet in here. So now you have enough tools to find the area of the circle. But how about of this square? They're telling me the diagonal of this circle, or mean that diameter of this circle is 10. And that actually, the diameter could be from here through here. All of this is the diameter. And if this is a square, this is 90 degrees. This side is congruent to this side here. and we're gonna have a 45, 45 right triangle. So I'm gonna picture it here. This is 45, 45, and this is 10. I'm looking for the one of the sides here. I'm gonna call this L, right? Actually, we're supposed to call it S, right? Because that's the side that you're looking for. Now, but because this is a 45, 45 right triangle, recall that this is your hypotenuse and this is your L. And in a 45, 45, 90 right triangle, we know that the hypotenuse is equal to L root 2, or you could have said that L is equals to H over root 2. And I think this is the most applicable, so L equals to 10 over root 2, and if I multiply times root 2 top and bottom, I will get 10 root 2 over 2, simplifying 5 root 2 feet. So that's what S is. That's the side of this rectangle, of this square, 5 root 2. Now we have enough to find the area of this shaded part. So the area that I'm looking for is the area of the circle with radius 5 minus the square with radius, with side 5 root 2. And we're talking about feet. Everything is feet. Okay, I'm going to put this as a reminder again here. Now, the area should be, I'm going to write the formulas again, pi r squared minus psi squared. Area is equals to pi, r in this case is 5, square minus a psi, which is 5 root 2 square. Area is equals to 25 pi minus this one here. We had to distribute it for each of them, so we had 5 square times root 2 square, which is just 25 times 2. So area is equals to 25 pi minus 50. All of these should be in square feet. So this is the area, the exact answer. Now, if I'm looking for my approximate solution, I have to type all of these on the calculator. So let's see what we get by typing on the calculator. 25 pi minus 50. So that gives us 20. I'm going to round it already. 28.540 square feet. That should be your answer, your approximate solution. So for this particular test, recall that you need to memorize your areas from the previous chapter that we learned, as well as your special triangles. And do not forget about the history about Archimedes. Where was he from? What city in Iceland he lived? What year did he die? And why was he naked? And what was the word that he should shout out? Okay? So do your best. Try the next following form or the test, and as well, the more problems you do, the better you're gonna get at them.